We all rely on other people to provide our food for us, whether it's being bought from the supermarket or from a restaurant. We want our food to be nutritious and tasty, but we also want it to be safe. And how safe do you think your food is? You might be preparing chicken on your bench at home. You're relying on the chicken to have been cleaned and processed properly coming out of the abattoir all the way through to the supermarket. How safe and how clean is your home? How safe are the techniques that you use to make sure that your benches and your cutting boards are clean as well? Let's start off by looking at how clean our benches are after we process raw chicken on them. The reason we might want to do this is to prevent cross-contamination of salad vegetables if we're preparing salads after we prepare the chicken. Now, some standard methods for determining microbial quality of food take up to a week to get an indication of how many microbes are on the board. That's too long for industry, it's too long for us preparing food in a kitchen. A really rapid method we might use looks at the amount of ATP on a bench. ATP is the chemical energy that microbes use. It's also the chemical energy that we use to keep ourselves alive on a daily basis. So if there's a lot of ATP on our bench, there's a lot of microbes. That tells us that our boards are quite dangerous. So we'll start the process off just by rubbing chicken on the board like you might do whilst you're cutting up your chicken. After that is clean the boards down with just Mum's detergent and sponge. We'll use some commercially bought lactic acid type cleaner, which is a cleaner you get from supermarkets. And we'll check this board with no cleaning at all, and we'll compare and have a look at which one is the cleanest. The reader will give us a reading in red, amber or green. It's a simple traffic light system. Red is dangerous, amber means you need to check your processes. If it's green, it's okay, there's not many microbes. So I'll begin just using Mum's sponge. So this is something you might do at home. You can use just the store-bought spray. And this one we won't clean, we'll just leave that as a comparison. So we grab our swabs, swab an area about 10 centimetres square. We pop the swab, mix it with the chemicals for the firefly reaction. So the more bacteria, the brighter the glow. Into the unit, and this unit just measures the amount of light. That's a very dirty board. So Mum's old sponge that you might use at home is not the best way of cleaning your boards. If we think about something like sushi, a sushi roll bought from a supermarket, you're relying on other people to make sure the fish is clean, the rice is clean, and you're also relying on them to wash their hands after they go to the toilet. We'll just start off sampling. So we need bits. So this is our automatic diluter. Okay, and we take it over to our stomacher. This acts like a stomach, mashes it up. So we just suck the sample up. So these are some examples of rapid plates. The standard plates take about a week to give us an answer. These plates are very quick to perform, and you get an answer generally within 24 hours. This particular plate here is measuring for E. coli in the sushi. E. coli is a good indication of fecal contamination of your food, and so people not washing their hands after coming back from the toilet. The great thing about these techniques is they really engage the students because they're very relevant for food studies. Students can choose the sorts of foods that they analyse, and they can choose the sorts of techniques that they want to walk through.